Hey, you. I was just watching a little bit of street activism, and one of the things that seems to come up quite often is the business of gravity and how that explains why this mud is clinging to this golf ball, because this golf ball has a certain mass, and as we all scientists know, that mass causes attractive force, and once that mass is great enough, it will start to pull things to it. So that's probably what happened here, is that this mud just happened to be near the golf ball as the golf ball traveled past it, and it got drawn in by the golf ball's gravity. Now, that obvious scientific fact to the one side, because, gravity is a proven fact. As you can see right here, I could get some water and pour the water onto this ball, and you would see the water sort of staying on the ball. I mean, some of it would dribble off, but some would stay on because of the attractive force of the gravity of my ball. Now, what I needed to explain to you today was that there's some other interesting phenomena or some interesting properties of gravity that don't really get discussed in the mainstream. I suppose the reason for this is because it's considered a little bit, unimportant. But given the amount of confusion that there seems to be out there, all these flat earthers saying one thing, mainstream science clearly saying something else, I thought it would be helpful if I tried to elucidate the topic somewhat. So I've spared no expense in my scientific endeavors. I went out and found myself a golf ball with its own small g gravitational attraction. In addition, I have also got this lighter, very expensive lighter. What I'm going to do is I'm going to rest this lighter on top of this ball, if possible. Perhaps I should have got something else. This lighter now is being attracted to my golf ball. Obviously, it's not going to work in the lab situation because my lighter is far too big by comparison to this ball. And obviously, this ball is minuscule by comparison to the Earth. The Earth is far too big for me to scale down to anything that would work. Obviously, it's worked in this case, and that's probably all the evidence you're going to need. Don't try and replicate this at home, although I could recommend going down to your local golf course, and you might find some of these as well that have generated their own gravitational attraction. Some might say full of shit, but I think in this case, quite clearly, it's scientific proof that there's a gravity occurring here. Now, unfortunately, in this case, it's almost done the same thing as happened on our wonderful planet, and that is that it sort of attracted itself to the golf ball in almost continental kind of formations here. If you'll imagine, this is some sort of Europe, maybe South America, or Americas. And if I was to just, say, spin these through a 24-hour day, I guess I'll go this way around. I guess you can imagine this being a sort of Earth-like experience. This is what Earth has. Oh, there goes Australia. Apparently it doesn't exist in some quarters, but scientific consensus says it does exist, and I know people who live there, so on that basis, I'm probably going to accept that Australia is there. Right, so let's move on. And Australia goes around for 24 hours. And all of the while, gravity is doing its wonderful thing. Now, all of the accoutrements, all of the cigarette lighters and water and people and planes and ships and so on are all going about their business. Now, none of them move very far in any single time. They're tiny, and the Earth is huge. But through the course of a 24-hour day, you'll notice that certain places, because the Earth is tilted at 66.6 degrees off the horizontal, you'll notice that some places will move their position. So, for example, this part of the world will sort of roll down like that and roll up like that through the as it goes around. So that's the kind of 23.4 or 66 inclination of the horizontal of the perpendicular. So what I wanted to draw your attention to is that this cigarette lighter, as it rolls through the course of its wobbles through the course of its 24-hour day, as the Earth floats in time and space, like Aladdin's thing, is that the amount of attractive force needed to hold it onto the top of the ball like this was X at this time, and then later in the day when it's over here, gravity does something wonderful, something that science can't really explain yet, but if I throw enough mathematical equations at it, and I'm going to get thousands of university students to do their best to come up with a form of numbers and letters that will explain how gravity is cute enough to realize that now the lighter needs X amount of attractive force, but now it needs X plus Y amount of attractive force, or face falling off the side of the spinning ball. It's not a conundrum. It is actually very a well understood science. We've been theorizing over this for thousands of years. Aristophanes' cousin came up with a similar experiment where he got a camel's testicles and got a couple of ticks to run around them, and found that the ticks never fell off. No matter where they happened to find themselves on the camel's testicles, they seemed just to be able to cling on. And so this stimulated the thought that once upon a time, before we used the term, the very obviously important term, gravity, we used to use testicle ticks as the explanation as to how it is that gravity will will require X amount of downward pulling, but once you moved your camel here, or your camel ended up over here somewhere, then there would need to be greater attractive force. Not that the camel's testicles or the humans or the water or anything else would ever recognize that they were being drawn by a more powerful force to prevent them from falling off of the underside. That's it. Again, that's the cuteness and the cleverness of gravity, or testicle ticks. Did I say that? Yeah, testicle ticks. So there you go, my friends. I think that's one of the curiosities of science finally unraveled. It is obviously only something that extremely genius people will understand. So if you're watching this, don't worry about whether this has made sense. Just go out and tell people that you fully understand testicle ticks or gravity, and therefore it explains everything that could possibly seem weird about living on a ball. I mean, I notice that when my lighter falls onto the flat surface of this table, it appears... Oh, man, stop. would you stop there? I mean, obviously, a scale is the issue here. We humans are tiny little minuscule, worthless ants, and therefore we are like ticks, and we don't, we're like this mud here. We're so small we can be attracted to this ball without any, knowing it. This mud won't ever fall off now because no matter what I do to this, the mud's attracted to this forever, and of course I can turn it up, I can do this, I can do that. But the lighter just, well, it seems happier on the surface. And so does the ball. Perhaps the ball Earth is sitting on a table. And it's not time and space, it's table that our ball Earth spins on. And of course, the friction between ball and table is not really an issue. So it just kind of just spins on that, and look how well that works. Look at that. I might be willing to accept that, but I don't know. Do rocks float in the sky? I don't know. Most people think so. I'm not sure anymore. I hope this has helped anyway on your search for gravitational attractive forces and the explanation of how the curiosities of gravity actually work. Thank you for stopping by, and I will have to say goodbye. Oh, good morning, Jack. Nice to see you, my friend. I must be on my way. I've got things of significant gravity to attend to.